video is on half-lives. So a half-life is the amount of time required for half of a sample of a radioactive isotope to decay. So that means that if I have a chunk of radioactive isotope, that over a certain period of time, it's the time of a half-life, T1 half of it decays away. And then, over the period of that half-life again, it's the time of a half-life, half of it decays again. And over the half-life period, half of it decays again. And again. And so on. So every time a certain amount goes by, and my sample gets cut in half, and in half, and in half, and in half again. If I keep cutting it in half, it'll never disappear. It'll just become smaller and smaller and smaller. So we can figure this out quantitatively, so looking at the numbers, by doing some half-life calculations. So if you have a piece of uranium that has a mass of 10 grams, after 5 minutes, how much is left if the half-life is 1 minute? So here I have my starting amount, my 100 grams, so that's my initial mass. So Mi is initial mass. After 5 minutes, so that's my total time. How much is left? So the amount that is left is my final mass. If my half-life is 1 minute, so that's the time of a half-life. So this means that every 1 minute, half of my sample decays. So we can make a chart of this. Here I have my time in minutes, my amount of uranium that I have left. At 0 minutes, I have 100 grams. That's my initial amount. After 1 minute goes by, my sample gets cut in half. So 100 divided by 2 is 50. Then another minute goes by and my sample decays in half again, so down to 25. After another minute, my sample gets cut in half again, so 25 divided by 2 is 12.5. Divided into again, after another minute, 6.25. And then divided a fifth time, 6.25 divided by 2 is 3.125. So this means that after my total time, I have 3.125 grams of uranium remain. I can do this in a more mathy way. My number of half-lives, we call N, is equal to my total time divided by the time of a half-life. My initial mass, which is Mi, in this case is 100 grams. My final mass, Mf, is what I'm looking for. So the first thing I need to know is how many half-lives are going to happen. I know that my total time is 5 minutes, and I know that the time of one of my half-lives from before is 1 minute. So 5 divided by 1 gives me 5 half-lives. This means that my initial mass gets divided by 2, or cut in half, 5 times. So my initial mass gets divided by 2 5 times. We can say 2 to the 5th, or we can say my initial mass divided by 2 once, twice, 3 times, 4 times, oops, those are 2's, 3 times, 4 times, 5 times, and that's my answer. So if we go ahead and do that, my original sample is 100 grams, divided by 2, divided by 2, divided by 2, 2, 2, 1, 2, 3, 4, 5, equals, if I plug that in my calculator, I get my same answer of 3.125 grams of uranium. Let's do an example together. The half-life of nitrogen-13 is 10 minutes. So that's my half-life time, so T of 1/2. If the starting sample has a mass of 2 grams, so starting sample, that means initial mass, how much will remain after 40 minutes? So that's my total time. So the first thing I need to know is n, my number of half-lives, which is my total time divided by the time of a half-life. My total time is 40 minutes, divided by the time of a half-life, which is 10 minutes. So 40 divided by 10 is 4. So this means that my sample gets divided in half 4 times. My original sample, mi, is going to be divided by 2 by the number of half times. So this is by the number n times. So my initial mass, mi, gets divided by 2 n times. So my initial mass here of 2 grams divided by 2 4 times. So that's 1, 2, 3, 4. We can do the same thing in a chart. My time and my mass. Here my time is 0, 10, 20, 30, and 40 minutes. My initial mass is 2 grams. So after 10 minutes it gets cut in half, so it gives it 1 gram. Then it gets cut in half again, so it's 0.5 grams. Cut in half again, 0.25 grams. And in half again, 0.125 grams. So you can either set up a table once you know your total time and your number of half-lives, or you can divide by 2 once, twice, 3 times, 4 times. Either way, you're going to get the same answer of 0.125 grams. My second example is a little different. Here I get told that I have 200 grams of an isotope, so that's my initial mass, decays to 25 grams, my final mass, in a total time of 24 seconds. What is the half-life? So I'm looking for my half-life. So it means I can't know n right away in the way that we did it before. So what I need to know first is n is equal to the number of times mi is divided by 2 to get to mf. So we'll make a chart to do this. We have our time, and then we have our mass. My initial mass is 200 grams, and that happens at a time of 0. I need to figure out, well, how many times do I go through to get my mass down to 25 grams? So each time it gets divided by 2. So 200 divided by 2 is 100. Divided by 2 is 50. Divided by 2 is 25. Well, this is the final mass I'm looking for. If I know that my total time is 24 seconds, I can put that in next to my 25 because this is the time that it took. So that means I got to 24 seconds going through 1, 2, 3 half-lives. So 24 seconds divided by my 3 half-lives means that each half-life must have taken 8 seconds. So my time was 8 minutes or 8 seconds. Then after another 8 seconds, I'm at 16 seconds, and another 8 seconds at 24 seconds. So this tells me that my half-life time is 8 seconds. I can do the same thing here by saying that I have my initial mass and dividing it by 2 until I get to my final mass. So that would be 200 divided by 2, which is 100, divided by 2, which is 50, divided by 2 is 25, divided by 2, is what I wanted. So that went through 1, 2, 3 half-lives. Same thing here. Time, total time, divided by n, which is my number of half-lives, is t1/2, which is 24 divided by 3, which is 8. So going about either way will get you the right answer.